Howdy, boys and girls. This is Mrs. Dunn. Today we're going to be talking about classifying numbers. Notice I put the title up at the top. So classifying numbers means taking a number and breaking it into which groups it belongs to. And some numbers belong to more than one group. So we have a Venn diagram that you got from me and Ms. Sarles, and we need to put that in. Now when we think of Venn diagrams, we usually think of something like this, where you have two circles that overlap. So we have people that like cats and people that like dogs. And then there is that group of people that like both. And they're right here in the middle. But some Venn diagrams can overlap all together. And that's what we have for our Venn diagram for this group. So when we classify numbers, we classify them as rational numbers, integers, whole numbers, and natural numbers. And as you can see, our circles are inside of the other larger circles. So when we talk about this, we are talking about how one type of a number can be part of more than one group because some of these numbers are inside the circles. Let's start with our natural numbers. Natural numbers are numbers that we just naturally see, or we call them sometimes counting numbers. If you go outside and need to count sheep, you would count numbers like 1, 2, 3, 4. So our natural numbers are those type of numbers. We're not going to go out and count 3/4 of a sheep. These are our natural numbers that are the basic ones that we talk about. Not included in the natural numbers, but included in the whole numbers is the number 0. Okay, so a whole number includes all of our numbers in the natural group, but also the number 0. As you can see, the natural circle fits inside of my whole circle. So if I related this to, say, where you live. You live here in Huffman, and we can say Huffman's like the natural group. So all the people that live in Huffman are here in this natural group. But sometimes we like to say, if you speak to somebody out of town, you live in like greater city of Houston. Like I say, I live in Houston. Even though maybe I don't really have a Houston address, I live in Houston, because not everybody knows where Huffman is, right? So we can say that in the whole group, we're talking about all the people that live in Houston. So there's lots of people that live in Houston that don't live in Huffman. Those belong over here, where my 0 is. But we who live in Huffman also call ourselves part of Houston, so we also exist in our own. So just like every natural number exists here on its own, it's also part of the whole number group. And we can extend that out even further. So we have natural numbers, our counting numbers, whole numbers, those basic numbers that we put on the number line. We can move over to integers. Now integers include all of our natural numbers like 1, 2, 3, 4. They include 0. But they also include all those negative numbers as well. Okay, all those negative whole-like numbers. So -1, -2, -3, -4, and so forth. They kind of go on and on and on forever and ever and ever. So we would count those as what you would see on the number line, but in the negative direction. So we can relate our integers to being like the people that live in Texas. In the city or in Texas, we have a bunch of different cities. One of those cities is Houston, where a lot of people live, but there are other cities. So there are other integers, like our negative ones. And within Houston, again, we have the people that live in Huffman. So a natural number is also a whole number, and it's also an integer. And a whole number doesn't have to be natural, but it can be. But every whole number is also an integer, because the integers take up the larger circle. Our last circle is rational numbers. A rational number is any number that can be written as a fraction. And that's most of them, right? There are rational numbers that are natural. Any of our whole numbers right here can be written as a fraction. 2 as a fraction is 2 over 1. You can say the same about integers. -4 over 1 is written as a fraction, so it's also a rational number. More rational numbers that we think of are things like 1/2. It's a fraction. Or -6.2. Notice it's negative, like an integer, but it has something past that decimal point. Or we could say 38 and 3/8. It's a whole number with a fraction attached to it. So the whole number 38, if we didn't have the 3/8, that would just be here as my natural number, a counting number. But because it has the 3/8 with it, it doesn't qualify as a natural number or a whole number or an integer. We would just call that a rational number. But again, my natural numbers, my whole numbers, and my integers are all inside that big circle of the rational. So the naturals, wholes, and integers are also rational numbers. So you here in Huffman, you as a natural number, you could say that you live in the greater city of Houston, which would be your whole numbers. You could also say that you live in the state of Texas, because you do, which are integers. And within the state of, or within us, we have the United States. So we can call our rational numbers like the United States. The United States has a whole bunch of different states. Texas is one of them. So a rational number has lots of different numbers that include integers, whole numbers, and natural numbers. Okay, so let's look at some examples of what that looks like. If I have these numbers, I have -2, 37, and 6.2. And I want to classify each of these numbers. Well, -2, I have that right here. -2, it's an integer. So I'd put integer, but every integer is also a rational number. So not only is -2 an integer, but it's also a rational number. Now, -2 is not a whole number and it's not a natural number, but it is an integer and a rational. What about 37? If we look back here in our Venn diagram, where would we put the number 37? Hopefully you'd put it right here in the natural numbers. It's our counting numbers. We can have 37 sheep. But notice again that that natural number is also a whole number, an integer, and a rational number. It's all of those things. So I'd write all of them. 37, it can be classified as a natural, whole, integer, and a rational number. My last one is 6.24, 6 24/100ths. That, if I look up here, could not qualify as a natural number, or a whole number, or even an integer. But because it can be written as a fraction, it would be considered a rational number. So it would only be considered a rational number. It'd be the United States, but not the state of Texas, where our integers live. Okay, so that is our lesson on classifying numbers. Over here on the opposite page, I want you to look at our whisk. My whisk is a little bit different this time. Make sure that you do this. You need to define in your own words a natural number, a whole number, an integer, and a rational number. Now, I just talked about all 4 of those, so if you need to rewind and go back, you can. But in your own words, tell me, what are each of those parts called? How would you define them? And then down at the bottom, for my check for understanding, I'd just like you to classify these 3 numbers. 2.7, 625, and -43. Just like we did over here in our examples, you're just classifying. What would you put those numbers at? All right, I hope to see these back. Thank you.